I think we can live with that. You can follow this presentation on the slides. I've posted on my Twitter page a link where you can grab the slides. My name is João Valente, by the way. I'm a software engineer from Porto. I've graduated in 2011. Life took me to participate in Startup Chile first batch. Then I went to Australia a little bit to participate in Angel Cube Melbourne, another accelerator. And then back to Porto. I love our country. I like to be here, and I like the way that our industry allows us to work remotely. So this is what I do. I helped part of a group of people that founded Porto Summer of Code 3 years ago. It's a tech fest in Porto. You should check it out when you have the chance. I work nowadays for a company called Doist. It's a company with around 50 collaborators scattered around pretty much 18 countries. There's around eight of us in Porto. It's a company best known for a tool called Todoist. There's another thing coming. Since we are a remote company, we started to feel like Slack couldn't handle like the amount of information that we generate in an organized way. So we start developing a tool for ourselves called Twist. You can see like the same paradigm as in Slack, where we have channels. On the right side, you have chat. But in the middle, we have something that really helps us keep organized. Basically, you can have conversations under a certain topic or a thread. So in the middle column, you see threads. And inside the channel, you can create threads. And threads have comments. So this is the tool that I will be talking about today. And in specific, my idea is to tell you about how do we present information to the user, how do we handle the complex data flows that we need to handle, how do we work with network requests, mainly when some problems arise, and how we handle the local data, or if you can rely on a local data for a certain request, or if you have to fetch it from the API. So this presentation, to be honest, I don't know how much time it's going to take. There will be lots of slides with code. So if you're not interested, you can keep doing whatever you're doing. Otherwise, I hope you bear with me. You can do me a sign if you're not understanding, or if you want me to give some details on the other stuff. So to present information to our users, we are using a tool that I don't know if you heard of, called React. React, as they say it, it's a JavaScript library for building user interfaces. And it's no more than that. When I hear people talking about, okay, are you using React? Are you using this? Are you using React? I'm like, yeah, you could, but what about the rest? Because it's just, like João presented before, a magic way to dump data into an interface, and React takes care of all the magic for us by optimizing all the DOM nodes that need to be changed. But not just that, there's also React Mobile, where you can also define components for mobile apps. So it's an abstract way of building interface components. So let's dig a little bit into React component. On line 12, you have a comment React component. It has a render method that basically returns a strange thing. There is a div with some props text inside. This is a React component. It has a type, in this case, comment. It has some props. That is some info that is passed inside that component, and it has children. So let's do an app, an overarching component, that will use our comment component, and that will pass it a prop on line 7. It will pass it a prop that is a string, simple string, that is hello world. Okay, then we use React DOM that basically is the specific part about dealing with the HTML and DOM nodes. And we will say that on the element that has the ID app, we want to render our app component. Basically, our HTML turns into this. You just need to specify an ID on a component, on a DOM node, let's say app. You load your JavaScript, and then you're inside React world. Of course, that you've seen some strange stuff like JSX or those HTML tags inside JavaScript. This is called JSX syntax, is the React syntax to specify the components, but you're not obliged to use it. I'm going to show you a little bit of this bundle file that we are loading. I'm going to show it a little bit about how it looks. So our code went through a transpilation process using Babel. It's out of context on this talk, but basically it grabs your JSX code, it transforms it into JavaScript. It also helps you using some functionality of ES6 and turns it into ES5 browser-ready JavaScript code. So as you can see on line 8, basically our divs, our comments, our app, they were turned into this React create element. And on line 8, you have the type, that is comment. Then you have the props, that is hello world. On line 20, you get the React create element. It's a native kind of element. That is a div. It doesn't have any children, and it has a props. Sorry, it doesn't have any props, and it has children. That is our string text. All right, let's stop for a bit and think. And this is like a bit of the web problem right now. It's kind of like a frenzy world where, you know, each week a new framework, a new paradigm, a new dev tool is up, and we have to keep up with it. We have to learn it, otherwise we start being uncool. But what we've just done is just stupid, because we've set up an NPM project. We are writing React components, and for that we are importing React. We are importing React DOM. We are transpiling code. We are doing a bundle, and just all this to do an hello world. So this is the part that I say, just think about what you're building, and if the only thing that you need is to render some like static table or some like non-very dynamic content on the browser and deliver it to the user, probably you don't need like a complex virtual DOM algorithm to work this stuff out for you. So, getting back to our example, we've defined a comment component, and now let's make it a bit more complex. Let's define a comments list component, and basically we can see that when we instantiate an instance of comments list on the constructor, we are setting the state. We've talked about props that are kind of like attributes that the parent can inject inside the children, but a React component can also have a state. A state is a way to store like internal information that just concerns that component. So we are doing some dummy, setting some dummy comments on the comments list state, and then on the render method, on line 16, we return an ordered list where we map these state comments, and we return our little comment component with a text prop comment. So basically, I think I'm missing a slide here. Anyway, we're starting to transform this, add a bit more complexity to this. Now let's do an overarching comments component, and that comments component will have our comment list, and we'll also have a comment composer. So our comments component started to have the state, and then when we render it, we will be rendering a div component that has children. There are comment list and comment composer. Our comment list, line 24, will get our comments that are a state on the comments component and will be props on the comments list. And we'll render a comment composer. The comment composer has an add comment prop. There is basically a method that receives a comment and pushes that comment into the state and sets the state, basically alters the state of our component, forcing a re-render. When we set the state on a component, the render method will run again with the fresh data. Our comment composer basically has a state that is the value of the input. And when it renders line 21, it will return a div that has two inputs, a text that will always have the value of our state. And then on change, each time that we change the input, it will update the value with a method on line 10 that will set the state, updating the value to the thing we've just typed. All right, I think we are ready. OK, there's also the submit. When you hit submit, we will run a method called add component that basically will call the prop that we got from the parent, and will basically go up there to the comments component and add a new entry to the comment state. OK, and then it resets the value, normal thing. OK, I hope that I'm not losing you guys, but this is what we get. We type a comment, we hit submit, we will call the add comment on the parent component, and we will get it. OK, at this point, we have a system that can render comments, that allow you to add comments, but this is not powerful enough. Like, imagine that you have other elements in the system that need access to those comments. Imagine that you want to do any kind of operation, like removing some old comments with other entities. So this is not powerful enough, and this is where React gets us. It renders interface. It's not very powerful with data. That's why I want to talk to you about Flux. Flux is more of a pattern than a framework, and the idea behind it is that we get unidirectional data flow. It introduces the concept of a dispatcher that knows how to deliver events around the platform, around your app. So let's start with a view, and let's imagine that our view is a React component. That view can trigger an action, let's say add comment, and that action basically delivers a payload to the dispatcher. The dispatcher then delivers this payload to all the stores that are interested in this action that just happened. After this, the store will say to the view, or to the views that subscribed, hey, I got new data, so do your stuff. This is Flux. You see a wildcard action at the left. This is because it is not necessarily a view that has to trigger actions. An action can be triggered by some kind of Comet server event, WebSocket event. So external entities can trigger new actions and change the data into your system. So let's talk a bit about the dispatcher. There is an implementation, a very simple implementation by Facebook that I'm using for the sake of this presentation, and we are actually using it also in Twist. And it provides you an interface with 5 methods. There is register. Any entity that is interested in some kind of action can register itself into the dispatcher and say, hey, I want to listen. Each time that this happens, I want to know. It can remove itself from that loop, of course. If a certain store needs to wait for another event on another store, for instance, to happen, it can explicitly say, I want to wait for this to happen before I do my stuff. And then there's the dispatch that are used by the actions basically, you can dispatch a payload that is involved in an action, and you have a verifier if, to see if something is dispatching or not. Because this implementation, it does not allow you to dispatch several things at the same time. And this is key because it helps you having a reason about your code. So if I'm processing an action regarding adding a comment, anything else has to wait a little bit before I finish this section, so I don't get kind of like actions going all around. You can bypass this, but I'm not, and I think it's a good practice to not bypass this. So let's now refactor our example, or enhance our example, in order to use this Flux architecture. You could see before that we were handling all the data inside the components, and the idea is that we won't do that anymore. So we have this comment store that has a simple structure, an array to store comments, a method, a function, to add a comment, and that's it. We have a structure. João talked in the previous talk about more complex and more suitable data structure to use and paradigms to use this, like immutable, but this is out of scope, so let's use an array to store comments, as simple as that. And we can see that our comment store is enhanced by the event emitter from Node, and it gains the ability to emit events, like the emit change method that emits a change event, and then it has two methods, add change listener and remove change listener, that can be used by any entity that wants to be listening to a certain event on the store, namely React components. Then our comment store adds itself to the dispatcher, or registers to the dispatcher, by saying each time the dispatcher sends something that is of the type add comment, I want to act on that. Namely, line 23, I guess, yeah. I will add a comment to our database, and then I will emit a change by saying, okay, I've changed. So now we've refactored, or we moved out of our React component the action of adding a comment. We made a new module called comments actions that has just that. When you call add comment, basically you're not changing nothing directly. You're basically saying to the dispatcher, hey, here's something for you. A new comment was added, and here's the payload that has to do with this change. As simple as this. Getting back at our little example, we can see that before we had on the comments component the add comment method. That is no more. We've removed it. We've also removed the state from the comments component because it is now handled by the store. So basically it becomes this. You could still get the comments here and then pass it as props to the comment list, but that is not necessary for this example because comments doesn't need to know about the existence of the comments database. But if you wanted, for instance, to count them and to show a little counter and you needed to fetch the comments, then you could pass it down to the comments list as props. Basically, the idea is that you only get the info you need when you need it and not before. So now we can see that our little comments list that will receive comments as props from the parent component, line 13, will now get the comments from the store, line 20. And basically, it will render the same exact way. And we can see that something happened here that is new. It was mentioned before, once again by João, but I'm going to talk about this a little bit. This is something that you get for free with React, that are life cycle methods. Basically, you get to act on your component when it will mount, when it did mount, when it will update, basically when it is getting new props or a new state was calculated, when it did update, which means that you can act on it after it flushed to the DOM. For instance, bring the focus to a certain input box or something. The should component update that basically allows you to trim the tree and say, okay, if the props are equal and the state is equal, I don't want to do anything else. I don't need to re-render. And the component will receive props. Basically, yeah, this sounds a bit complex or far-fetched, but it basically means that you could get new props, but the change would not update, so the component will update will not run. Instead, component will receive props, will run. Okay, I don't know if you have any questions, but I think I will leave it to after. But long story short, React also gives you lifecycle methods that allow you to act on your interface component at different stages of its existence. So, with this in mind, we can see that the comments list component will, when it will mount, before it mounts, it basically says to the store, hey, when you change, I want you to render this method of mine. There is the onChange method, line 15. And when comments list unmounts, basically it stops existing, it deregisters himself because, you know, don't need to be clogging the machine. Basically, each time that the store changes, this force update that I'm calling here will trigger a re-render. It's the same thing of simulating set state. Set state will re-render the component, but you can also force if the state didn't change. Okay, so basically, right now, I still want to go to the comment composer to tell you that the line 17, where we were calling the add comment from the parent component, will stop existing, and we will instead call the add comment from the comment actions. So, here's what we've done. We've separated the data and put it in the stores. We've separated the actions and put it in the actions. And we have this structure that is easier to reason about. And it's actually the only way, or not the only way, but having like this approach of this separation of data from the React components is the only way to do complex apps using React. You could also use Redux. I'm not going to talk about it. It's a bit different, but it's kind of the same thing, to separate. We can act on data, and this is all local. So we need to go internet. We need to interact with the server. We need to fetch data. We need to store data. So in our particular case, the Twist API, it allows us to do batch requests. And a batch request consists in compressing a series of requests that you want to send to the server, and just send them out in a list to the server. The server will process them one by one, and then return you the responses all at once. So you will have to process them. Okay, let's enhance a little bit our comment actions in order to not only store our data to the store, the comment store, but to also send it to the server. I've added this method, sync actions, on the line 7, which means that besides dispatching an add comment to my local, to my store, to my comment store, I will also trigger a network action that is of the type add comment. The payload will be comment, and I have that priority. This priority will allow me to process different actions with different priority. Basically, if a user triggers something using the interface, I want it to happen right now. But if I'm doing some update or background fetching this could wait a little bit. So that API requests add comment is basically an object. You can see on line 18. It has a type. It has the indication of the HTTP request method, that is a post in this case, and has a URL. Basically, this sync action is my black box where I send my network requests. And note that I've did the dispatch to add a comment. The store got it. The store emitted the change. So this comment is already on my interface while I'm processing this. OK. Let's talk a little bit about this sync actions add. Basically, it gets a request, that is this add comment object we've talked about. It gets an object with parameters, and it has a priority, as we've talked about. And now, the sync job. We create a sync job object. What does it mean? It means that at this moment, I will have an instance of a sync object, the sync job, that knows a lot of stuff about a particular request. It knows that batch requests means that it's all the payload that I will be sending to the server. It has the information about if there were any errors. It has information about if it was retried or not. So basically, I'm mixing the local data and the network data that I will be using in the same object. And basically, I'm creating it, and I'm adding the job on line 272. I'm adding it to basically a queue that prioritizes this job based on its priority, like we've talked about. OK. So now, let's see that we have our queue with 5 or 10 jobs, and now it's time to sync them. Basically, we can see on line 84 that if we are already syncing, we will postpone this a little bit and wait for it to hold. Then I will get, on line 89, I will get a slice of the jobs that I have in the queue, let's say from 0 to 5, and I'll call it my processing queue. This will be the queue that I will be dealing with right now. On line 95, I have this dispatch, just to remind you that we are inside the sync actions, and the actions can dispatch at any time some kind of job that can be handled by stores, by React components. So let's say that I have a logger or I have an error checker, and right now in this else, if I don't have nothing in the processing queue, I'm just saying to whatever entity wants to know about this, I'm OK. There are no errors, there are nothing in line, it's all good. OK, as you can see, if I have sorry, I should have highlighted the code that I'm talking about. I hope you're following, but I'm on line 91. If I have something to process, I will process. So let's dig a little bit into the process queue method function. OK, I will basically go through each job that I have in my processing queue, and I'm start building my requests object. Request array, sorry. Basically, I'll get that batch request part, that is what I need to send the request to the server, and I push it to the requests. And bear in mind that we are doing a batch request, so we will have like five, for this example, 5 jobs that will be processed, like add comment, edit comment, add comment, add comment. These 4 jobs will be sent to the server at the same time. So what I'm doing is I'm building an array of requests. I'm setting the params I need to send this batch. In this case, I'm signing it with a token and a client ID. And on line 113, there's something that is interesting as a dev tool. I can, when I'm in development mode, I can add a parameter to my requests to say, OK, with this percentage of, with this amount of percentage, I want you to fail. So if I set this KO monkey to 50, and if I sent an add comment request, there is 50% chance that the request will fail. This is good because while you're developing, you want stuff to fail so you can act on it. So this is a way of introducing some noise while I'm doing this batch request. Okay, line 1-to-1, I will be sending away formatting my request. This could be using fetch, XML, HTTP request object, anything. I'm sending my request away. I'm adding a success callback and an error callback. At this stage, as we are batching, if this call fails, it means something like very critical, or either you are offline or either your token is expired. So what I will do, is just tell that to the user. I'm not going to go into details because this is not the interesting part. What I want to tell you about is about when this batch request succeeds. What happens? So let's dig a little bit into the add callback method. It will get a function inside that basically will grab the responses that we got from the server and send them into the dispatcher of the batch requests. It has nothing to do with the dispatcher we've talked about previously. We will now dispatch the responses that we've got from the server. And bear in mind, on line 3, that we are sending the responses we got from the server, and we will be also sending the processing queue we had locally. Okay, I told you there will be code. Now it's the time that we got a success response from the server. I will go through each of the job that I know was processed on line 6, and I will start reasoning about it. Basically, I will get its code, its response code, and its body response. So I know that if the code was between 200 and 300, that the response was OK. So I can safely, on line 13, dispatch this response to the store. Let's say that we have comment add. That action type will be comment add. The response will be whatever it is, either the comment object or an OK. And then I will send the local data. Imagine that, let's fall back a little bit or go back a little bit and say that I've optimistically added, if you can remember, I've optimistically added a comment to my interface that I still don't know if it was delivered successfully to the server. That is why, still on line 13, I'm sending the job parameters. All the local information that I gathered about that object, in this case comment, it will be also sent to the store. Let's say you had a temp ID to that temporary comment. So the store will get this, and it will do whatever it has to do. In this case, it will look into the job params and see what was the temp ID. It will remove that from the comments list and add the comment that the confirmation that I've just added a comment to the server, or we'll add the comment the placeholder comment that I already have on my database and say, okay, now is your final ID, it's all good, you were persisted. So this is one OK response, and from here, the sync actions has nothing to do with the data. It was delivered to the stores, and our stores were just processing this data and signaling the views about all this. Now, the strategy we are using for the errors is to basically dispatch the same structure, but we will append line 17 an underscore error to the job type. So this will trigger an add comment error to my action type. The response will be the error that we've got, and we will send the local data. And this is particularly important because I can have my comment store handling this error particularly. let's say that if the add comment failed, I want to go to that particular comment with that temp ID that I've optimistically added to my interface, and I want to say you failed. Or let's say that I want to remove that comment. Or let's say that I want to signal a flashy pop-up saying, hey, you failed. So this is a way for me to have the stores listening to these errors and acting accordingly, either in a particular way, like removing a comment, or in a more general way by saying your action failed because of this. Basically, on line 19, I'm saying that if the method was get, and if it was a forbidden or if it was a not found, I will just ignore that because I cannot act on that. You can revert from a forbidden or from not found. So I've considered that job as done. But inside that, this if on line 19, I could say, I could dispatch a generic error by saying, dispatch this error that is, this action was forbidden. And then I could just show with a React component that could be like the notification supervisor, it got that error and it displayed the message directly to you. If this was not one of these get, forbidden, not found objects, what I will do is I get that job, I will increment, and if you remember the sync job, it had a retry attribute that I will increment, and I will say, okay, this response will be inside this job errors array. So I still have a sync job that has all the information about how it failed, how much times it failed, and I can act on this by retrying. Okay, so yeah, this is kind of it. Basically on line 31, I'm checking if I have any errors, and I'm dispatching basically a status job sync that it means exactly what I told you. We have a supervising component that if you got any errors, it will be listening to this type status job sync, and it will say, okay, I got all these jobs that failed. What can I do with this? I can send a Raven exception. I can notify the user. So I've abstracted all the error handling to a component that can deal directly with that. Okay. Oh, wow. 36 minutes. Yeah, I could show you a little bit about how we handle local storage, because I kind of promised, but I believe you guys are bored. Anyway. Okay, I promised to show a little bit how we handle the local storage. This is something that I'm not particularly satisfied with, because local storage a pain in the ass. Like, you have to serialize and deserialize text. But you know, this is kind of like what we have right now. As you can see here on line 9, you can see the code. You can see the code. Just a second, guys. Okay. Here, I have this like small wrapper around the local storage that exposes a set and a get. It instantiates an instance of a storage. And here in the storage, what we have is a little bit of a cache around the local storage, so we don't need to be eating the local storage all the time. So when I try to get, basically, when I do a get, I'll try to get it from the cache. And if I get it from the cache, I return that cached value. Otherwise, I will fetch it, and I'll return it to the user. And to set is the same thing. I'll set it in the cache, and I'll persist it to the local storage. As simple as that. When I initialize my stores, basically, I can have an empty object, or I can have like some fancy immutable data structure. It doesn't matter. What it matters is that I will retrieve the comments from the local storage, and at this point, as you can see, I've abstracted the local storage. It could be like WebSQL, whatever. I will populate my comments on my comment store via the local storage. As simple as that. Then, on my comments component, you can see that on the constructor, I'm calculating the state. Here. Here I'm calculating the state of this comments component. The state will be what thread is loading, what's the thread, what are the comments for this thread, and the rest is just, yeah, I'm not going to talk about it. Basically, when I'm calculating the state of these comments for this thread, God, I can see the board in your faces. I'm sorry, guys. I mean, you are here, so. When I'm calculating the state, I will see, okay, do I have this thread? Do this thread have any comments? Okay, let me step back a little bit. Basically, when I'm calculating the state, I will try to fetch the comments for this thread from the comment store. This is how it is. I'll try to get the comments from the store. If I don't get any comments, but this thread indicates to me that there are comments, what I will do, surprise, is I will say to the comment actions, please do a request to the server to fetch the comments for this particular thread. While I'm at it, I will say, okay, I'm loading this thread in particular. And my component will know that I've got a thread, I've got no comments, and I'm loading this thread. So basically what I will do here is, if this particular thread is loading, I will not show the comments list. I will just show a loading screen. Then we are inside the Flux structure, meaning that I'm showing a spinner. The action was dispatched to the server. The server answered, hopefully, in the correct way. And then, when the store gets the comments, it will signal, OK, I've changed. I have new data for you. And basically, because my comment component is subscribed to the changes on that store, I'll just say, OK, I'll calculate the state again, I re-render, and my comments will be there. Basically, as you can see here, I'm not subscribing to any kind of error store or nothing like that. So basically, I didn't want to add anything more complex to this. Basically, if something fails, you'll keep having a spinner. In this particular case, the spinner won't stop until you get comments. But we have that error appended to if the request failed while fetching comments. I'll have an error triggered, and then a managing component will see, OK, so this get comments failed, and I will just show a message to the user by saying, OK, I could not fetch your comments. OK, so we went through adding a bit of complexity to a React app. I'm sorry if my thought wasn't that structured. This is the first time that I talk about, that I do like kind of a technical presentation. So yeah, this was it, and I'm sorry if I bored too much. And yeah, thank you. I'm ready for some discussion. Thank you. Any questions?
Hi.
Hey.
Do you prefer Flux to Redux, and why?
I don't have enough knowledge about Redux to tell you about it. I know that I like this event kind of paradigm because, as you can see, I can like trigger events from the actions like kind of arbitrarily, and I don't need to be dealing much with like the state. And I believe like Redux, it's not like this event-driven kind of flow. It's more about reducers and getting like the changes and the state and calculate a new state and just spit it out. So I want to, and that falls a little bit in the category of all the trendy stuff that is going on. I've seen like Dan Abramov talking about Redux in React Europe 2 years ago, and it's funny because he developed Redux just to help him doing other stuff. That was the auth loader dev tool, so that was kind of a side project. He got a lot of traction inside the community. I think the Flux guys and actually then was hired by Facebook, and I believe that Facebook is using Redux and not Flow anymore. So I just can't keep the pace of, I can't refactor the whole app right now to use Redux. I would like to experiment. I will experiment. Right now, I don't have enough knowledge about Redux to say if I prefer one or the other. I'm pretty sure it's kick-ass because the guy is kick-ass. So yeah,
Thanks.
Sorry. Okay, yeah, I guess, yeah. I couldn't make myself clear, or you guys are just too bored. Okay, anyways, I guess I think I hope that you've learned something, and I will be around. And if you're shy and you want to say something like you're a dumbass that don't know how to program, and you want to say it in private, I appreciate it. But please come and tell me because I love to learn. So thank you very much.